Okay, so something came up and I'm not going to be here today. Obviously, you figured that out. But it might be a little different depending on which class you're in as to how far we got. This is where we got at the end of second period. And if we got this far or finished this problem, you can skip ahead, obviously. But these are your continuation of your notes yesterday. There's a hard copy available online. Everything should be done on it. But we had a little bit of cutoff stuff too. So let me pull off the actual saved copy. This is -1 and this is -7. And then we can finish this problem and move on to the rest of the stuff. So what I did yesterday, the last thing I did was I kind of put that one right there to line things up. And I'm going to rewrite that just so it's not all bundled up. I'm not at the board anymore, so I have lots more free space to do things. So -1.5g plus a half of f is a -1, and -half of g minus 1.5f is a -7. So yesterday we attacked m's. We eliminated m twice. We got down to equations with just g and f. And now we're going to eliminate something. The numbers really aren't that the best, most complementary, but I'm going to actually attack f, because if I triple this thing, I'll get a positive 1.5. And that'll counteract that negative 1.5 there. So I'm attacking f. You could attack G. It doesn't matter which letter of the alphabet you do. Sometimes it's just easier. So I'm going to triple the top equation. That would be -4.5G plus 1.5F equal to a -3. Almost made a copy mistake. That's equal to a -7. And I'm going to recopy the bottom equation. And I'm going to add on down, because if I add on down, there are no more F's. So -4.5 plus a -1/2 is a -5G, and a -3 plus a -7 is a -10, and I have a G value of 2. So it looks like granola is $2. Okay, granola was $2. And normally we write ordered triplets here, but we're not going to. We're talking about the price of snacks. We wouldn't put that as an ordered triplet. We're going to go ahead and plug that back in, and it doesn't matter what equation you plug it back in. For simplicity purposes, just keep things kind of standard. I'm just going to put it there. So -4.5 times 2 plus 1.5f for fruit is a -3. And a -4.5 times 2 is a -9. And if I'm going too fast for you, it's called the pause button, kids. That's what it's called. Now we're going to counteract the subtraction of 9 through addition. -3 plus a 9 is 6. And if you divide both sides by 1.5, you can check me with a calculator if you want. You'll find that fruit cost $4 per pound. Okay? So, if you were breathing yesterday, at this point in time, you realize that we take these two things and we plug them into something up top. It doesn't matter what equation you do. I'm just going to go to equation 1. I'm going to plug into this 1m plus a half a g plus 1f equals 8. So the only thing I don't know is m. So m plus a half of g, and g is 2, plus a fruit at 4 must be 8. Now half of 2 is 1. I mean, half of 2, kids. You hold out 2 fingers, you take half. Uh-oh. Probably shouldn't record that. But 1 plus 4 is 5. We're going to subtract that 5, and we got $3. So the mixed nuts was 3. The granola was 2. And the dried fruit was 4. That's how you finish that problem. Now, I skipped over a lot of stuff yesterday. I was trying to focus on little things instead of opposed to some other ideas. If you'll go back and look at the notes you took, we have classifications of systems still to talk about. I never talked about it. Now, I'm almost certain, I could be wrong, but most of your homework has answers. They all are all classified the same way. I don't want to spend an entire day talking about how you classify systems. So these are the three things you know. A system that has an answer, a legit answer. All right? We come up with three answers for X, Y, and Z or whatever, is classified as independent consistent or consistent independent. Now, that's not a big thing to know in Algebra 2. Occasionally you see questions on the ACT about classification. You're doing enrollment courses, and the farther you move up, knowing little things like this, they start making a bigger deal out of it. If a system has infinite solutions, it is classified as a dependent system. And it's actually classified as consistent dependent. So consistent dependent. Now, a system that doesn't have any answers, the no solutions tells us we have inconsistent. It's an inconsistent system because there's no solutions. But, yeah, and that's just it. There's no answers. So we have consistent independent, consistent dependent, and then we have an inconsistent system. Those are our three big classifications. And there's certain things that show up. So here's a system with no solutions, which we would classify as inconsistent, which already answers a question on the piece of paper. Certain things show up when you do these. Now, I'm going to attack, looking at it real quick, I think I'm just going to go after y. So I'm going to attack y. I'm going to see what happens. I could just take the first and second equation and I could add them together. Because that would eliminate a y. So that'd be 4x plus 3z's is a negative 2. Now remember, you got to eliminate the same thing twice. So now I need to pick on a different pairing. The next pairing I pick on is going to be those two. And what I'm going to do is I'm going to 4 this guy. I'm going to take everything in here and I'm going to multiply it by 4. If I was using a pencil, I'd write that. But I'm going to 4 this thing. 4 times 3 is 12x. 4 times a negative y is negative 4y. 4 times 2 is plus 8z. And 4 times a negative 5 is a negative 20. I wish I'd left myself more room. I didn't. It's one of the dangers of doing things in pen. And I'm going to add those together. And I'm going to get 16x, there are no y's, plus 12z equal to a negative 27. Now, I've done this for years. I already know there's a problem. When I look at these two equations and I ignore the constant, I see that this equation right here is a multiple of the second equation. So I know there's a problem here. And maybe you'll be smart enough to figure that out ahead of time too. But you're still going to have to do a little bit of work just to kind of see exactly what it is. So I'm going to take this equation right here. I'm going to move it right there. 4x plus 3z is a negative 2. And I have to 4 it because I want the x's to disappear, or the z's, it doesn't matter. But I'm going to 4 this sucker. And I'm going to get 16x plus 12z equals a negative 8. And again, I probably wasted a little bit of time. I probably should have shown this and done it all in one swoop. But I'm going to retrace that right above because I like to line things up. And then I'm going to subtract down because I want the x's, and in this case, the z's to disappear. So 16 minus 16 is nothing. 12 minus 12 is nothing. You can say minus nothing or plus nothing, it doesn't matter. And a negative 27 minus a negative 8 is a negative 19. Now, you actually have something here that is complete nonsense. 0x plus 0z is 0. That is a false statement. It is false. That's how you know something has no solutions. You get a false statement. That's how you know it has no answers. You get a false statement. So we classify it as inconsistent. And What you're supposed to catch on to is that algebraically, you get a false statement. And it's always something. It always looks like 0 equal to some number. Always. Anytime you see 0 equal to some number, you have a system with no solutions. And I don't know if that shows up on your homework or not. I really don't. It might not. It's one of the standards in Algebra 2, though, that you know that, so we're going over it. That was a system with no solutions. There is also in your notes an example of a system with infinite solutions, although I have no idea what I did with that copy. Kind of funny that I already lost it, but I did. Let me print it off again. It's crazy, I just had it. Oh, it was right in front of my face. How about that? Organization, something I've never really had. So here's an example of a system with infinite solutions. And of course, there's notes up here. This is different years that I've taught this. This year has been way different. Everything has been done in an entirely different order with y'all. But here we're going to do a system that has infinite solutions, and we're going to be looking for something. There is something that shows up in this. Now, I've got these arrows here suggesting I'm going to do something here. It looks to me like I'm trying to link equations 1 and 2. And what I'm going to do is I'm going to do some straight subtraction, okay? I'm going to do x minus x. That's nothing. That's no x. I'm going to do y minus y. That's no y. I'm going to do z minus a negative z. Well, that's kind of cool. Z minus a negative z is 2z. And then 4 minus 4 is nothing. Now I'm going to link these two equations together, all right? I'll have to do a little bit of work. I'm going to have to actually triple this thing, and then I'm going to do subtraction. And I'm trying to rush through this on you. I'm not trying to waste a whole bunch of your time. But 3x minus 3x is no x. 3y minus 3y is no y. 3 times a negative z, which is kind of cool. So 3 times the negative z is negative 3z, and if I take away another z, I get negative 4z. And then I have 3 times 4 is 12, and 12 minus 12 is 0. So let's just focus on what we had here. We had 2z equals 0, and we also had that negative 4z is 0. Interesting. Well, there's really no need to do the elimination method here. I mean, you can. If you double the top, you'd have 4z equals 0 and a negative 4z equals 0. And when you add those together, you get 0 equals 0. That's what you end up with, which is kind of interesting. This is a true statement. It's true. When systems equations work out like this, you actually have infinite solutions. And next year, we'll talk about this. Right now, I don't care about that. That's not anything I care to talk about with y'all. But when you see 0 equals 0, you have infinite solutions. So we'll just kind of make a note on that. If you see 0 equals 0, you have infinite solutions. Now, what does that mean? If you're curious, look it up. It means that these lines, and these are actually lines, are the same exact thing. They really, really are. They're the same exact thing. So that's what it means. So be on the lookout for that true statement. All right. I guess we need to move on. There was only one other thing in your note that we need to talk about, and that's this guy right here. Another word problem, and it's the last word problem in your note. So when you're done, you can work on the homework assignment, and I'll go over that when I'm back on Friday. So Jesse, Maria, and Charles went to the local craft store. Poor Charles. He must have got drug into that. I don't know. Maybe it's his thing. Maybe Jesse's a boy. Maybe Maria's the only girl. But Jesse purchased 3 sheets of craft paper, 4 boxes of markers, and 5 glue sticks. Well, let's talk about Jesse. He's the first equation that shows up. And we did this yesterday, and second period at least seemed to understand how you write the equations, and that is the easy part. When you talk about Jesse, he got 3 sheets of craft paper. So I'll say 3P for paper. He got 4 boxes of markers, so plus 4M. He got 5 glue sticks, so plus 5Gs for glue. And his bill was $24.40. There's Jesse's equation. And then we have Miss Maria. She spent $30.40. That's the thing on the other side of equality there. She spent $30.40. She bought 6 sheets of craft paper, so 6Ps, 5 boxes of markers, and 2 glue sticks. And lastly, we have Charles. Poor Charles. Charles only spent $13.40. You can tell he didn't much care for this activity. Or maybe he was just well stocked. He bought 3 sheets of craft paper, and this is a real thing because my wife is into crafting and it's a very expensive hobby. But she's having fun with it, and happy wife, happy life. Notice I never say happy husband, happy life. It's because we don't matter. Our job is to support and be there. We're the tough ones. Remember that. It's part of being a man. You don't matter anymore. Accept it and teach your children to be the same. Our job is to take care of others. But anyways, there's our 3 equations. It's just like anything else. You write the equations, then you attack a variable. And you could attack your P's, your M's, your G's. And I kind of like the way these P's are looking. 3 minus 3 is nothing. I could double a 3 and get a 6. So that's what I'm going to do. I'm going to just focus on the first 2 equations. And I'm not going to show the work because I'm trying to save some time here. But 3 minus 3 is nothing. 4 minus 2 is a 2, so plus 2 markers. 5 minus 1 is 4, so 4 glue sticks. And $24.40 minus $13.40 is, I hope, $11. And that says 0P, not OP. That's a 0. Put a slash through it. 0P. The next thing I want to do is I want to work with a different pairing. I'm still attacking P. You've got to pick on one thing twice. You know that. Pick on one thing twice. And I'm going to do these two for no good reason, but I'm just going to pick on these two. And what I'm going to do is I'm going to double and subtract. I'll write that in words, but I'm not going to show it. So I'm going to double the third equation and subtract. So 6 minus 6, because I'm doubling, is nothing. 5 minus 4, because I'm doubling, is 1. 2 minus 2, because I'm doubling, and this is really awesome that this happened, is 0. And 3040 minus 2680. When you double this, you get 2680. 3040 minus 2680, 320, 1360. That seems a little expensive here. I screwed that up really bad. 3040 minus 2680 is $3.60. I added 10. Didn't mean to do that in my head. Now, you could keep working with this. Like, there's some things you could do here. You could play the elimination game if you wanted to. If I had a highlighter, I would highlight this line right here. It literally says that a marker is $3.60. That's what it says. I hope you see that. It says that a marker is $3.60. So since I know what a marker is, I can go ahead and I can plug that back into this equation right here. And that's going to tell me what a glue stick costs. So twice a 360 plus 4 glue sticks must be $11. And glue sticks aren't going to be too expensive. $3.60 when you double it is $7.20. Then we're going to take away 7.2 from 11. And 7.2 taken away from 11 is 3.8. Yeah, it seems right. So 4G is $3.80. It's actually dollars. And I just got to figure out how many times 4 enters $3.80. Almost 9, really close to 9. 4 would enter 320 80 times, so that'd be 80 cents. And you'd have 40 cents left. I must be having a moment here. You'd have 60 cents left. So 4 times 80 cents is $3.20. There's 60 cents left. 4 enters 60 cents 15 times. So what am I coming up with here? 95 cents. A glue stick is 0.95 or 95 cents. So we now know the cost of a marker. We now know the cost of a glue stick. And we just plug that into any equation we have. And Charles' equation actually has the smallest numbers. So we're going to use Charles' equation. That way I can do it in my head. So 3 pieces of craft paper plus 2 markers at $7.20 plus 1 glue stick at 95 cents is $13.40. Now I'm going to do a little combining like terms. I don't know why I put a 7.2 there. It's a 3.6. I must have been thinking ahead. I'm guilty of that. But twice 7.6 is $7.20. Plus that 95 cents must be $13.40. If you take $7.20 and you add 95 cents, you'll get $8.15, still equal to $13.40. So then we have to subtract that $8.15 from $13.40. Let's see, $13.40 is 3.4 away from 10, and $8.15 is $1.85 away. So we take 3.4, we add $1.85. It's 4.4, 5 and a quarter. 3p is $5 and a quarter. Then we just have to figure out how many times 300 is 5 and a quarter. And that would be $1.75. So paper is $1.75 a sheet. Glue sticks are 95 cents a sheet. And markers are $3.60 a sheet. And kids, I did all this math in my head on 3 hours of sleep. Why don't you all start thinking a little harder? It can be done. I was a little slow on it because I lack sleep, but it's still doable. Anyways, you guys need to work on your homework. Don't expect me to come in Friday and reteach what I put on a video for you. That's on your end, not mine. Have a good day, and we'll go over your homework tomorrow. I suggest you do it. Maybe be ready for a quiz. I don't know. I'll think of something. Anyways, have a good day.